This video lecture is meant to cover the information found in Chapter 10, Section 3 on percent composition. Percent composition tells the relative amounts of elements in a compound. It is described by the mathematical equation of percent composition is equal to the mass of the element divided by the mass of the compound, multiplied by 100 to put it into percent form. There are three approaches to percent composition that you will be required to perform, and I've broken them down into three sections on your video lecture handout. The first strategy is when you're asked to find percent composition from mass data, as if you had done an experiment to find the masses of the individual elements. The first problem here says that when a 13.60 gram sample of a compound containing only magnesium and oxygen is decomposed, 5.40 grams of oxygen is obtained. What is the percent composition of this compound? So the compound contains two elements, magnesium and oxygen. 5.40 grams was the oxygen. 13.60 was the mass of the compound. So if we subtract those two, you will find out that 8.20 grams is the mass of the magnesium element, because 13.60 was the total mass of the compound. To find percent composition, you need to do it for all the elements of the compound. So I'm going to start with magnesium. We'll have to go in a minute. We'll do the percent composition for the oxygen. So the mass of the element, in this case magnesium, is 8.20 grams. We'll divide it by the mass of the entire compound, 13.60 grams, and we'll multiply it by 100. In your calculator, we will maintain three significant figures because our initial measurements had 3 sig figs and 4 sig figs, so we'll have to use the fewest, and that works out to 60.3% of this compound is magnesium. Now oxygen, 5.40 grams of the compound, divided by the total, 13.60 grams, times 100 will give you the 39.7% that you might have expected had you subtracted 60.3 from 100%. But doing the math here verifies that your first answer was done correctly. So this is what we call the percent composition, because we now know the relative amounts of the elements of a specific compound. So that's the first approach. You were given the individual masses of the elements to start. The second approach, all you'll be given is a chemical formula. Propane, C3H8, is the fuel commonly used in gas grills. It is one of the lighter compounds obtained from petroleum. Calculate the percent composition of propane. Well, because we have the chemical formula C3H8, and if we have a periodic table which has the average masses for these elements, we can easily calculate the percent composition. So starting out with C3, there's 3 carbons, and from the periodic table each carbon is 12.0, so that's 36 grams of carbon. There are 8 hydrogen, times the mass of one hydrogen is 1.0, and so the mass of the hydrogen in this compound is 8.0. Adding it up, the total mass of this compound is 44.0 grams. So finding the percent carbon, we take the mass of the carbon, divide it by the mass of the entire compound, and multiply by 100. This works out to, if we maintain 3 significant figures, 81.8% carbon. Now if we do this for hydrogen, you might be able to predict what the percent should be if we take 100 and minus 81.8, but let's verify to make sure that we didn't make any errors on our first calculation. So the mass of the hydrogen, the hydrogen is 8.0. I'm going to divide that by the mass of the total compound, 44.0, and multiply by 100 to get a percent composition of hydrogen of 18.2%. And of course those two numbers do add up to 100%, so that's a good check of our work. The third strategy is when you are given, this is still a chemical formula, but now we're not finding the percent composition of individual elements. We're going to look at a hydrated salt. Sometimes it's called a hydrate, but we're going to find the percent water in this hydrate. And so a little background, a hydrate you can recognize from its formula. This example right here, this is nickel 2 nitrate with 6 water molecules attached, and there's usually going to be a little dot to show that those 6 water molecules are weakly attached to the ionic compound. So what we want to do is find the percent by mass of the water, and we're going to divide that by the mass of the entire compound. Right, so to do this, and I'll write that down, we'll find the mass of the water divided by the mass of the entire compound, including the water. And then, of course, multiplying by 100. So to do that, we'll find the molar mass of water, and if you add up 1 oxygen and 2 hydrogens, that works out to 18.0 on the periodic table. But there are 6 of those water molecules. So 6 times 18 is 108 grams. So that's the mass of the water. 18.0 times 6 is 108 grams. So that's where the mass of the water is for the numerator. The denominator is, we have to find out the mass of the nickel nitrate and then add that to the 6 waters. So in the denominator, we're going to add the 108 to the mass of whatever the nickel nitrate adds up to be. And using a periodic table, nickel is 58.7. The 2 nitrogens together are 28 because each one is 14. And then there's a total of 6 oxygens, each at 16, for a total of 96. And so adding it up, we have, oh, let's see, what is that? That's 0.7. Let's see, that's 2279, so 182.7. And so this then becomes 108.0 divided by 290.7. Multiply that by 100, and you will get 37.2% water. So in this percent composition, there's only going to be one percentage that you'll be calculating, and that's the percent of the water in a hydrated salt. And again, it's the mass of the water divided by the mass of the entire compound, including the mass of the water. And then, of course, multiplying by 100 to get percentage. You'll have some practice problems to try in class, so get those from your teacher. And I guess this concludes the video lecture on percent composition. We'll see you in the classroom.